Hi, and welcome to Galaxy 5 Math. Please don't forget to like and subscribe.
Okay, so we're talking about quadratic equations, and all it is a second-degree polynomial, which is a polynomial with a sum of exponents of variables equal to 2. So x to the 1, y to the 1 would be a second-degree polynomial, and then x squared, of course, would be a second-degree polynomial. Okay, so we're going to look at the equation 8 minus 6x equals 4x squared. And to write this in standard form, we'll pull everything over to the left-hand side, and we will actually have it in descending order for the exponents, for the degree of the exponent. So we start with our x squared component and then go to our just x and then our number without a variable there. So that is actually standard form, and that is how we're going to look at it before we solve a quadratic equation. Okay, so we have our standard form and everything's on the left side. Now we're going to look at the general form of the quadratic equation in standard form, and it's usually denoted by ax squared plus bx plus c equals 0. So a, b, and c are just constant numbers. They're the coefficient to these variables, and they're just any number, any real number. Okay, so a quadratic equation is going to have at most two numbers or two roots that will make the equation true, so that at the end of the equation you'll end up with 0 on the left side equals 0 on the right side.
All right, so now we're going to look at the graph of a quadratic equation. And this graph is of the equation we just wrote down just a minute ago. And because of that negative, it's going to be an upside down parabola. So those roots, or the answers to the equation, are right there as graphed on the x-axis.
Okay, so here we're going to let x equals -1 and then x also equal 4. And these are going to be our two roots or our two solutions to the problem, so that at the end 0 equals 0 and the statement is true. So we are simply just plugging in -1 in for x on that left side, and then x equals 4 in for x on the right side. And it all works out, and as you can see, and we check it and everything looks good.
So that you can see those numbers and the solutions to that equation, again, you can look there at the x-axis and you see that intersects at -1 and 4.
Okay, so the zero factor theorem states that if p and q are any real numbers and you multiply p times q and it equals 0, then either p equals 0 or q equals 0, or they both p and q equal 0. Okay, so this helps us figure out by factoring what our roots are, and it shows us where this graph is going to cross the x-axis, where y equals 0. Okay, here we have a problem, -64 equals -16x squared. And so we're going to pull it over and make it standard form so that everything is on the left side. With 16 and 64, we have perfect squares, and I will eventually make a factoring video so that you can see this again, but since these are perfect squares, we can factor this by saying x minus and x plus, and then we fill it in with our perfect squares. So it will be 4x on in each parentheses, and then -8 and then +8. we can check that back out with our full method and everything should cancel out nicely. So, all right, now because we have p is 4x minus 8 and our q is 4x plus 8, we can set each of those equal to 0. And then we're going to solve for x. So if we add 8 to both sides, we get 4x equals 8 and 4x equals negative 8. Then we divide both sides by 4, and then we divide both sides by 4 again. So we're left with x equals 2 and x equals negative 2 as our roots. Now we can plug these back into the original equation to check and make sure that these roots make the equation true. So when we plug 2 in, we get negative 16 times 4, and then negative 64 on the other side. And as we continue to solve that right side, we see that negative 64 equals negative 64. So that is true. Now we're going to plug in negative 64 equals negative 16 times negative 2 squared. But just like 2 squared, negative 2 squared is going to be 4. So it's essentially going to be the same thing from here on out. And negative 64 equals negative 64.
All right, so you can see those answers of x equals 2 and x equals negative 2 on the graph. You can kind of see them. The numbers are so large that that negative 64 makes it a long graph.
Okay, so now we have the equation negative 36 plus x squared equals minus 9x. All right. So then we pull everything over to standard form and we have x squared minus 9x minus 36 equals 0. So we can go ahead and put our x's in each parentheses. And I just want to remind you that when you multiply two negatives, you're going to end up with a positive. If you multiply a negative and a positive, you're going to end up with a negative. And if you multiply two positives, you end up with another positive. But, so the negative 36 is, of course, negative. So you're going to have a negative and a positive in each one of those parentheses.
Okay, so now that we have figured out that we need a negative and a positive in each one of the parentheses, we need to figure out what is going to multiply together to equal 36 and add to equal negative 9x. So let's write out some of the factors of 36. Okay, so we have 4 and 9, 6 and 6, and 3 and 12. And our middle term is minus 9x. So anything that we add together has to come out as negative 9. So our larger number should be negative and our smaller number should be positive. So I think that the best way to do this would be to put 12 minus 12 and then plus 3. When we do our full method, we end up with x squared. Our inner is 12x, or sorry, minus 12x. Our outer is plus 3x, and our last is minus 36. And when you cancel all of this out, you end up with x squared minus 9x minus 36 equals 0. So it works. It matches what our original equation is. So that's perfect. So now we're going to take x minus 12 to be p and our x plus 3 to be q, and we're going to set each of them equal to 0. So when we do this to solve for x, we end up adding 12 to both sides and end up with x equals 12 and adding minus 3 to each side and getting x equals negative 3. And these are our roots, and we'll solve the equation and make the equation true. So these x values on the graph are where the graph intersects the x-axis, where y equals 0. So these are the points where it will intersect. Okay, so we have our coordinates here for this equation that we just solved. And again, you can see them on the x-axis where y equals 0. So that is 12, 0 and -3, 0. Please make sure you like and subscribe to Galaxy 5 Math to get more quality algebra instruction.